All right, today's notes, 7-2, ratios in similar polygons. Here, this symbol represents similarity polygons. There are two ways to prove that polygons are similar. First way, angles are congruent. Second way, sides are proportional. All right, so let's talk about a similarity ratio. It's a ratio of lengths of corresponding sides. Okay, so you know how I am. That's very wordy, right? Let's put that into play. Let's look what look at a math problem to see what that looks like. So here we have two triangles, and it says, are the polygons similar? If so, give similarity statement and ratio. Guys, this is very important because students tend to forget one or the other. So we're asking you to find two different things, a statement and a ratio. So notice what we're given are all three sides of this triangle, all three sides of this triangle. So the problem is we need to figure out which one goes with which. And what I mean by that is, do you see how here we have two angles of this triangle? Now we know that we can add those two together, subtract from 180, and we get that this angle here is 48 degrees. All right, well, process of elimination says 90 and 48 is going to probably leave us a 42 degree angle here. Now the reason why those are so important is because those tell us which sides go together. And what I mean by that is, if I start with my smallest angle, 42 degrees, do you see how he is directly across from this side of 6? Here, 42 degrees is directly across from this side of 12. So guys, we can set them up in a ratio of 6 to 12. This side is proportionate to this side. All right, let's do that again. Let's go with our middle angle, which is 48. He is directly across from 8. And this 48 is directly across from 16. And then our 90, directly across from 10. And this 90 is directly across from 20. Now, we know 6 over 12 can reduce to 1/2. 8 over 16 reduces to 1/2. 10 over 20 reduces to 1/2. So their ratio is a 1 to 2. Here's your ratio. Now it's asking you for a similarity statement, and several questions on your quiz for this week will do the same. So now we need to talk about how we're going to set them up. So most of us are going to go with ABC. Like that's just human nature. So similar ABC. So notice that angle A is 48 degrees. Over here, who is 48 degrees? Angle X. Angle X. Then we went angle B, which was 42, so angle Y. And then C was 90, Z is 90. So triangle ABC is similar to triangle XYZ. Guys, I wrote that so wrong. I'm so sorry. I said it right. Triangle ABC is similar to triangle XYZ. Let's say that again. Triangle ABC is similar to triangle XYZ. So you're making sure that your angles are aligned in each one. So I want you to think back to the very first unit that we ever covered. Angle A goes with angle X. Angle B goes with angle Y. Angle C goes with angle Z. So this is your similarity statement. So here's our ratio. Here's our similarity statement. Here, so I want you to think length and width. Do you see how this guy is shorter? So length and width. Length and width. So we have 18 to 36. 12 is to 26. So guys, this is not as easy to see as the first one, right? So 18 divided by 36, we get a 0.5. 12 divided by 26, we get a 0.46. So guys, these two are not proportional. So therefore, they are not similar polygons. All right, here, we can do the exact same thing as we did on the previous one, thinking length and width. Okay? Length, width. Now, your similarity statement is going to look a little different. So guys, I tend to put the smaller polygon over the larger. And let me show you what I mean by that. I can see that this side, EH, is proportionate to this side, AD. Then I have this width of HG should be proportionate to this length, DC. From here, I can set up my ratio. 6 is to 4x minus 2, as 7 is to 5x minus 4. Now guys, this plays directly off of 7-1, cross multiply, making sure that when you do multiply, you're multiplying both terms. So we get 30x minus 24 equals 28x minus 14. So I'm going to move my 28x, add my 24, and I get x is 5. But then it may ask you for the length of these sides. So if I take 5 and plug it in, so 4 times 5 minus 2, I get a width of 18. And then 5 times 5 minus 4, I get a length of 21. All right, example 4. The vertex angle and base angle of an isosceles triangle is in a ratio of 8:2. All right, lots of words going on. Vertex angle, so I know that's going to be the top guy, right? And then it says base angles of an isosceles. So isosceles means that these two legs are congruent, which means the base angles are congruent. And they're in a ratio of 8:2. So guys, if these are isosceles, then both of these base angles are going to be the same. But think about it. What do we know about all three angles of a triangle? They equal 180. Remember, those are ratios of 8:2. So 8 times something plus 2 times something plus 2 times something will give us 180. Combine like terms, divide both sides by 12, and we get x is 15. So it says to find all angles. So we're going to say 8 times 15, 2 times 15, and 2 times 15. So we get 120 to 30 to 30. Here would be your angles. The angles in an octagon are in a ratio of 3 to 4, 3 to 4 to 6, 6, 7 to 8 to 10 to 10. Find the angles. Okay. So, just like up here, we used our ratio and set it equal to the amount that all three would total, right? All three angles we know total to be 180. Yeah, that might not be so easy when we're talking about an octagon, right? So, we know in an octagon we have 8 sides. And if we're wanting to find the total, you got to think back a couple of units. 8 minus 2 times 180. If you plug that into your calculator, 6 times 180 is going to give you 1,080. Guys, that is the total for an octagon if we were to add all the angles together. So then we're going to do exactly like we did in the triangle. 4x. And then the entire thing is going to equal our angle measure of 1,080. Combine like terms. If you add all of that together, I'll save you a little bit of time. You get a 54x. Divide both sides by 54, and we get x is 20. Now guys, you can take that 20 and plug it in to find all of your angles. 3 times 20, 4 times 20, 6 times 20, 7 times 20. to get your angle measures. For the sake of time, I won't do that on this video. Here, guys, I would star number 6. It's probably one of the most missed questions. 2 consecutive angles of a parallelogram are in a ratio of 4 to 5. Alright guys, it's been quite a few minutes since we've talked about consecutive angles. So if you think back to that, consecutive angles equal 180. They're in the ratio of 4 to 5. So then we would have 4 times 20 and 5 times 20. And there we go.